Welcome to today's webinar, announcing AWS Personal Health Dashboard, view and manage the health of your AWS resources. Our presenter today is Ram Ator. Ram is a Senior Product Manager here at AWS. We also have Scott Barneson, James Aitken, Brian Condi, and Carl Zoller. They will be serving as our webinar moderators and will engage with you and answer your questions throughout the presentation while Ram presents. Ram, welcome. The floor is now yours.
Thanks, Ryan. Hello, everyone. I'm Ram Ator, and I'm a product manager at AWS. Welcome to the webinar about AWS Personal Health Dashboard. It is my honor and privilege and extremely excited to talk to you about the AWS Personal Health Dashboard and the AWS Health Service, a new service that we launched a couple of months back during re:Invent 2016 on December 1st. During this session, I will talk to you about the various capabilities that we launched and the value proposition they offer our customers. I'll briefly touch upon the reasons AWS invested in building this service. I'll go a little deeper into the service and explain various components that interoperate to provide you with meaningful information to better manage your applications running on AWS infrastructure. I will then walk you through what is required to get started with the service, and getting started is super easy given the close to zero setup that is required. I will then demonstrate the dashboard in action using a few use cases that have been modeled based on real customer use cases that we observed during the private beta program for the product early last year. And I'll close out with what to expect in the next few months. We announced several capabilities, and one of them is the AWS Personal Health Dashboard, which gives you a personalized view of the status of your AWS resources, your accounts, and the services that you use. The information surfaced on the dashboard will include issues with any AWS service or particular resources, scheduled activities such as any changes to the infrastructure powering your resources, or notifications that are specific to your account. With this awareness that is specific and contextual to your AWS usage, you can quickly see AWS issues that may impact your applications. Now, why is this important? Working closely with customers during times when they saw impact to their applications on AWS, we observed that customers spend precious time troubleshooting on their end to answer the question, is this issue caused due to a wrong configuration, buggy code, or a bad deployment from the customer's end, or is this issue actually due to an underlying AWS infrastructure problem? We heard this feedback consistently from customers, and by the usual Amazon way, we listened and delivering version 1 of the solution. The AWS Personal Health Dashboard will help answer this question quickly by proactively notifying you when we know an AWS service is impacting your resources. Not only will the Personal Health Dashboard provide information about events impacting customer resources, but also remediation guidance where applicable so that customers can resolve the issue. For resource-specific events, you will be provided with deep links to take the remediation actions in the respective service consoles. The dashboard will also surface remediation steps by providing links to relevant knowledge articles and AWS service documentation that is familiar to customers. Getting the information surfaced by the Personal Health Dashboard and the health service into the right hands is crucial to ensure that the right parties are aware of what is required and the action that needs to be taken in response to this information. For example, we may want all storage-related health notifications to go to a storage team, all networking-related notifications to go to a networking team, or all security-related notifications to go to a security team, and so on. Customers can set up custom notifications through CloudWatch events by specifying rules to extract events of interest and wire targets such as SQS, SNS, Kinesis, Lambda, and built-in CloudWatch actions. All personal health dashboard notifications specific to customer resources and accounts will be accessible on the CloudWatch events channel. Here's a quick look at what the personal health dashboard landing page looks like. I will be demonstrating this dashboard in detail in a few minutes, so hold tight. The dashboard is available to all customers free of charge. The URL to access the dashboard is provided on the screen. We also launched the AWS Health APIs that power the personal health dashboard. The AWS Health APIs will be the authoritative source to vend health-related information for all AWS services in all regions. The APIs allow integration with in-house and third-party systems used by customers for monitoring and event management. Please note that these APIs are available to business and enterprise support customers to power their integrations. The ability to configure notifications and trigger automated actions through CloudWatch events for personal health dashboard alerts is available to all customers as well. The personal health dashboard notifications are accessible through the new Alerts widget on the AWS Management Console navigation bar. These alerts will persist across service consoles and provide customers a personalized view into service health no matter which AWS console they are on. I will be demonstrating this along with the dashboard in a few minutes from now. And we also have dozens of resource-specific event types and hundreds of service-level event types with more to come in future. I'll spend a few minutes to explain why AWS invested in building this new solution. As you all know, we started Amazon Web Services way back in 2006, bringing in the decade-long experience of running reliable, scalable, secure, and cost-efficient massive web infrastructure powering Amazon.com. We launched the AWS Service Health Dashboard in 2008. Back then, the AWS cloud was relatively new, and the Service Health Dashboard was a good way for our customers to check on the status of each service. You can look at the screenshot and see what the dashboard looked like back in 2008. We had a few services and a couple of regions. We have come a long way in the last 8 years, both customers and AWS. Today, the AWS global infrastructure is comprised of 16 regions and 42 availability zones worldwide. And AWS has been continually expanding its services to support virtually any cloud workload. And we now have more than 90 services that range from compute, storage, networking, databases, analytics, mobile, management, and so on. Additionally, the cloud has become the new normal, which means that companies of every size are now deploying new applications to the cloud by default and are looking to migrate as many of their existing applications as they can as quickly as possible to the cloud. Customers from different segments are deploying applications ranging from financial applications, SAP deployments, e-commerce applications, websites, analytical applications to crunch petabyte scale data, and many, many other diverse applications. What all this means is that when you pay a visit to the current Service Health Dashboard, you probably are more concerned about the status of the AWS services and resources that you are using rather than about the overall status of AWS, given the unique nature of the applications you're running on AWS. We've already invested a lot in providing visibility over the years through CloudWatch metrics and alarms for customers' virtual resources. And we also launched AWS X-Ray during re:Invent 2016 that provides debugging and analysis capabilities for microservices with request tracing. Now we are moving into providing visibility into issues with the underlying infrastructure. In order to provide you with additional information that is of direct interest to you, we invested in building the Personal Health Dashboard. This service will provide increased transparency and provide meaningful information related to your resources, your accounts, and services that you use on AWS. As I mentioned earlier, the dashboard will surface remediation guidance through deep links to specific service consoles, knowledge article links, and links to AWS documentation to help with quick troubleshooting and diagnosis. The Health APIs support easy integration with in-house tools to automate workflows, and custom notifications set up through CloudWatch events, rules, and targets provide a predictable way to ingest notifications. And you can set up Lambda as an output channel for automated actions to help with auto remediation as well. Let's see how the Personal Health Dashboard works under the hood. Customers can choose, as I said, from a plethora of options, 90 plus services to build reliable, secure, and scalable solutions on AWS. Each of these services publish what we call events to the AWS Health Service. An event is any occurrence in AWS that has significance for cloud IT management. That is the definition of the event we're using in the Personal Health Dashboard. So an event can be operational, billing, or security in nature. As you can imagine, it is a complex problem with 90 plus services running in 16 AWS regions to quickly correlate degradation of underlying hardware to customer-specific resources. We are investing in engineering effort to attribute issues with services to customer resources to better correlate impact. When all of the various services publish events into the AWS Health Service, the service aggregates this data from all AWS regions into replicated data stores for redundancy and offers a global view of information to customers. The service also decorates the event with customer metadata to make the information more meaningful by providing additional context. For example, the health service automatically pulls all the resource tags set by customers and adds it to the event. And then this information is made visible to customers in various ways. One of them is a Personal Health Dashboard, a global console that customers can use to view events from all regions at a glance without having to toggle the region selection on the AWS Management Console. And a set of APIs to access the information in a programmatic fashion. We have launched 6 different APIs that can be used to create multiple types of applications. And push notifications through CloudWatch events channel, where you can set custom rules to extract events of interest, and wire targets that will be triggered when an event is matching a particular rule. The programmatic channels can be used by customers to integrate with in-house and third-party monitoring and event management systems to automate workflows, reducing the operational burden of managing complex applications. On this slide, I want to spend a few minutes to explain the various service integrations that we have today. We have a bunch of services already integrated with Personal Health Dashboard. To highlight a few, we have Amazon EC2 that publishes EC2 instance schedule changes, dedicated host schedule changes, EC2 auto recovery failures, performance degradation with instance stored drive, and so on. You no longer need to rely on emails for these important notifications that will help you immensely in your troubleshooting and operational planning. We also have event types dedicated to provide more visibility into networking related issues. This has been one of the top asks by customers who run business critical and mission critical applications. So these event types will provide visibility into intra-AZ, inter-AZ, and AZ to internet networking issues. When I say AZ, I'm referring to the availability zone. And this will be for both classic and VPC customers. And this information is surfaced on the Personal Health Dashboard and the Health APIs. Amazon EBS publishes events related to issues with EBS volumes. And Amazon RDS publishes scheduled changes for database instances and any issues with the underlying storage. Elastic Load Balancing publishes events when there are insufficient IPs in the subnet, causing the load balancers to not scale. The Amazon Elasticache publishes scheduled changes for the Redis and Memcached clusters. Amazon SES publishes notifications related to verification of domains before you can begin sending emails. SES also publishes information about DKIM verification status. The AWS Direct Connect and VPN publish scheduled changes for the resources. You may have seen a lot of emails about these scheduled changes in the past. Amazon Cognito publishes details about misconfigured roles that don't allow Cognito features to function properly as a service cannot access the required resources. Amazon Elasticsearch service publishes notifications when issues are detected with the capacity of Elasticsearch domains. A scale-up would be required to get the system back to normal operations. And you will see this list growing rapidly over time. Personal Health Dashboard also provides information regarding service level issues such as API errors, latency, or connectivity issues for all the AWS services. So all of them are integrated and live as of today. The AWS Personal Health Dashboard and APIs will surface events occurring in all regions for your resources and services, except the AWS Gulf Cloud and the AWS China regions as of now. We'll be adding support for this very soon. Now to the really exciting parts. Getting started is super simple, as I mentioned earlier. You need to sign up for an AWS account if you don't already have one. The AWS Personal Health Dashboard requires authentication, unlike the Service Health Dashboard. You need to have credentials for an IAM user for which the Health IAM policy is attached. The policy allows access to the APIs powering the console. And no IAM policy is required if you log into the root credentials, of course, of your account. As a best practice, please refrain from using root credentials as you cannot restrict permissions for root account credentials. You should delete root access keys and use IAM user credentials for everyday interaction with AWS. And the same holds true for interaction with AWS Personal Health Dashboard as well. That's it. With this setting, you're all set to access the service. There are a few ways that you can reach the Personal Health Dashboard console. First, when you visit the AWS Service Health Dashboard or the AWS status page, you will see a link to open the Personal Health Dashboard, the yellow button on top there. Second, you will find links in the AWS website. In the My Account section drop-down, you will see Personal Health Dashboard. You will also find links to the service in the top left-hand menu, along with the other AWS services. And third, as I mentioned, we built a persistent way to provide customers a personalized view into service health, no matter which AWS console you're on. The bell on the navigation bar can be clicked to open a menu, and each item in the menu is deep linked to relevant sections in the AWS Personal Health Dashboard. Let's take a look at what the dashboard looks like. This is the landing page of the AWS Personal Health Dashboard. The dashboard has been designed keeping in mind timeliness and criticality of information surfaced. Events are bucketed into 3 categories or 3 tabs, as you can see here. The first category provides a list of issues that are open, meaning they're impacting your resources and account and potentially impacting the services that you are using. These are items that need your immediate attention, and once these issues are closed or resolved, they move away from the dashboard and end up in the event log section. The second category provides a list of any changes to the infrastructure powering your resources scheduled to occur. So the status of these can either be upcoming or ongoing based on the timestamp and what is happening with the event. And once completed, they move from the dashboard landing page to the event log section, similar to open issues. The third category provides a list of notifications that are related to your AWS account. They can be operational, billing, or security in nature. So an operational notification can be an introduction of 63-bit instance IDs that may impact your operations if you have some kind of special logic based on the instance ID length. or it could be a deprecation of SOAP protocol, and so on. With billing, we have end of free tier notifications, notifications related to change in tax for a particular month, and so on. And for security, we have an example of ELB disabling support for SSL v2 due to a security vulnerability that was discovered in the SSL v2 protocol itself. These are all notifications that AWS has been sending over the years through the email channel. Customers consistently requested for a better way to be notified of such important events. So with the Personal Health Dashboard, all of these important non-marketing notifications are aggregated into a single view, and it's available over the Health APIs as well. The event log section provides a list of all the events across all categories with a historical view of 90 days. All tables, as you can see, they had this filtering ability on top. They support powerful filtering capabilities, which I'll demonstrate through a use case a little later. Let's go back to the slides now. Let's see how to get started with the Health APIs. The Personal Health Dashboard is powered by the Health API, and we are making the APIs available for integration through the AWS SDK. APIs are available today in all languages and platforms supported by AWS SDK. The endpoint to access the service is health.useast1.amazonaws.com. Remember that this endpoint will provide events from all regions, not just US East 1. It can be a bit confusing. The Personal Health Dashboard and Health APIs, as I mentioned, are global in nature. So region is just a parameter used to filter events. You use the same endpoint specified here and use a filter of US West 2, for example, to view events related to US West 2 region. We also launched a command line interface for the service, and documentation for the API and CLI can be found in the link provided here. Please note that at launch, the APIs and command line interface are available only to business and enterprise support customers to power their integration. Let's look at a few demos. I've got a few use cases, all modeled based on customer use cases. We had a private beta that ran for a year, and we saw what customers did, and we built the dashboard and the service to help with those use cases, and we're going to demonstrate a few of them. The first is a troubleshooting scenario. I'll walk you through what this workflow would look like. I'll go back to my console here. Let's assume that my website is running on AWS, and I notice that my customers are beginning to see errors when they're loading a particular page. My application monitoring systems are alarming, and I'm trying to figure out how to solve the problem. As I mentioned earlier, troubleshooting can sometimes be frustrating if you're unable to pinpoint quickly whether the issue is due to a change on your end or if the issue is because of an underlying AWS infrastructure. Customers running mission-critical and business-critical applications on AWS provided this feedback consistently, and we listened. We're starting with the AWS console because customers spend a lot of time here or in any of one of the service consoles. And we wanted a persistent way to communicate a personalized view of service health. So we built notifications into the notification bar, into the navigation bar on top here. And you can see that it is represented by this bell icon. So let's go back to the scenario where my application monitoring systems are alarming. The first thing I'll do is see the orange dot next to the bell, signifying that there is at least one open service issue relevant to my resources. Clicking on this bell provides detail regarding relevant events and notifications for my account. And I click on Open Issues to investigate. This brings me immediately to the Open Issues tab in the Personal Health Dashboard. This screen looks familiar to you. This is the landing page. So I see that there is this EBS lost volume event that occurred recently. I click on this particular event and I get details about what actually happened to this event with the root cause, and I get links to specific knowledge articles and AWS documentation for me to fix this particular problem. There is also a section here called affected resources that provides details about the specific volumes that had an issue. So in this case, it surfaces the volume ID of this volume as well as tags that have been assigned to this particular volume by me. As I mentioned, this is a deep link. So if I click on this volume, it takes me straight to the EBS console, and by default it searches for this volume, and I can take required remediation action on this particular volume. So I take the required actions and my website is back to normal operations. But there's more. Since we integrated with existing AWS primitives like CloudWatch events, and because our notifications are delivered programmatically, customers can introduce automated remediations for relevant event types. So there is a link here which is set up notifications with CloudWatch events. I can click on that. It takes me to the CloudWatch events console. And in here, I can create rules to capture events of interest. Let's say that I'm interested in capturing all EBS volume lost events, and I want to attach a particular target to it. So I can select an event source of AWS Health. There are multiple sources here, and AWS Health is a source that is used by Personal Health Dashboard notifications. And you can specify additional rules to filter the events further. So I'll say EBS, and I'm interested in a particular category of event type, which is an issue because of lost volume is an issue. And EBS volume loss is available here as an option. So this is my rule, and you could create advanced rules by going into the JSON editor. So whatever rule I created there is provided in JSON format, which I can edit or add to make it more complex. And any event that matches this rule will trigger targets that I assign here. So in this case, I'm going to start off with a Lambda function. So the other targets specified here are available as well. So I wrote a script called the EBS volume lost handler. So whenever the AWS EBS volume lost is triggered, it causes EBS volume lost handler. And what this Lambda function does is it finds the latest snapshot, it creates a new volume based on the snapshot, it detaches the old lost volume and reattaches the new volume to the instance, and the instance is backup. So with this, my website is backup and there are no issues. So essentially what I've created here is a self-healing kind of remediation for my website, and it is resilient to all the lost volume notifications. So we can take this further by adding a lot of customized Lambda rules that you can author yourself for various types of events, and you can have targets that will be triggered to take any kind of action that you wish. So let me end the scenario by quoting Werner Vogels that resonates with this use case. So he said, everything fails all the time. We take this very seriously at Amazon and architect our systems to be resilient. You can look at our strong operational performance and adoption of AWS by customers over the years. During rare situations, however, customers see impact when there is an issue with an AWS service. So you need to ensure that you follow best practices of having snapshots for volumes in this particular case, following multi-AZ architecture, and keeping a close eye on services such as AWS Trusted Advisor that assist you in building reliable, scalable, and secure applications while being cost effective. Let's now look at the second scenario. As an application owner, I want to look at all the events that are specific to my application. And I'm going to use tagging as a way to identify my application in my AWS account. Let's go back to the dashboard here. And I'll start off with the event log section for this particular use case. As I mentioned, the event log provides a list of all the events across all categories for this account that I've used to log in. So I'm going to demonstrate how the filtering capability works here. The service supports multiple filters. It's pretty flexible. So I'm going to pick up tag as a filter. So it supports key value as entries. So I'm going to pick up the key as app. That's what I've set for my application, and the value as website. So this query should return all the events that have resources with tag, app, and website as a value. So you'll notice that of all the events that are displayed on the screen, there are 4 events of interest to me because I have for this particular app website. And I can go further, I can add another tag. Let's say I'm interested only in production stage. That's another important consideration because you don't want to wake up in the middle of the night to fix an issue with Gamma or test if it's not required to be done immediately. But if it's a prod application, you may want to work on it immediately. So the same filtering capability is available on the APIs and the CloudWatch events channel so that you could trigger different kinds of workflows based on the severity of impact as defined by you. So if I say prod, so the 4 events got further filtered into 3 of them. So these 3 are something I want to take a look at. The EBS volume is what we just saw. And I see that there are 2 upcoming scheduled changes. So I need to plan for that beforehand so that I don't see impact when something is done for this infrastructure. And you did not notice because I'm on full screen, but every time I put in a new filter, the URL on top is going to update to reflect whatever filter I'm adding. So this essentially acts as a reporting functionality. As in you could take this URL and you can share it with your team members. And if your team member has access to the personal health dashboard for this particular account, then they'll be able to just paste in that URL and they get the same view as you see here. So they need not repeat the process of adding the various tags that you had set up. So it can be used as a good reporting tool. Let's go back to the slides now and look at the third use case. So we want a way to route notifications automatically based on the metadata of the event. So as an example, we can consider routing all security notifications to a particular security SNS topic or a security team. So let's go back to the slides and start off with the dashboard section. So I'll go to the other notifications here. And I see that there's a security notification. So this happened March of last year. I just picked it up as an example. So this is something that we sent out to customers through email when SSL v2 had a security vulnerability and the Elastic Load Balancing team stopped support for SSL v2 to protect our customers. So this is a notification that we may want to route to a particular centralized security team. So let's see how we can do that through CloudWatch events. So again, you come to this create rule. When you click on the deep link in the personal health dashboard, you can select AWS Health as the source selector. And I can select security as a service. So we have chosen security to be the service label for any security related notification. And in this case, the type category is an account notification, which represents the third category of events on the personal health dashboard. And we can have a specific type code, let's say it is AWS security notification. So whenever there is an AWS security notification, I want to, let's say for example, notify a particular SNS topic, which is managed by the centralized security team. So I've enabled an SNS topic called my security team, and this could be configured to either send an email or an SMS or have a callback URL. So whenever an event that matches the particular rule, then it triggers this SNS target and notifies the people who are subscribed to this particular topic. Now we may want to do this across multiple accounts because with centralized teams and as customers grow big, the number of AWS accounts used by the customer will also increase. It will be more than one. So what we can do here is we could author a CloudFormation template and run this rule across all the different accounts, and with that it's configured across accounts, and we're able to get this cross-account view to this particular topic or particular target. So at launch, we are able to provide APIs and the personal health dashboard view for a single account. We will be working on multi-account view over time. The other integration that I want to show as part of this use case itself is integration with Slack. So I authored a rule, a Lambda function, which is called my Slack notifier. So what this does is whenever an event of this particular rule is created, it calls this particular Lambda function and it notifies my Slack channel. So I actually have this Lambda function here. So you can configure webhooks with Slack as an example, and I have this webhook here, and whenever that particular event occurs, it's going to notify that particular channel. So just before this demo, I triggered that security notification as an example, and I created into my Slack channel something called a security health room, and created a webhook called health security webhook. And any notification that is triggered with the particular security rule is automatically plumbed to my security health room. So I can work with my team here, and my security team is aware, it's across accounts, and I get notified about any security related notification. So you could think of creating a similar one for the other types of applications or event types that you have. So you could have rooms for different websites or different stages of websites and so on. So this is an example of how you can route notifications, but you could create any other kind of integration that you use internally in your company. So the ability to filter by tags or use CloudWatch events to route notifications and take automated actions through Lambda will allow you to continue receiving a return on investment you have made in adopting foundational AWS primitives. So we've reused existing primitives that we have adopted so that you continue to receive the return on investment. Let's go back to the slide and take a look at what else is coming. As I mentioned earlier, it is a complex problem to quickly correlate impact with the 90 plus services, the underlying problems with 90 plus services to customer specific resources. So our focus is to invest with service teams to correlate degradation of underlying hardware with customer specific resources to provide more timely notifications in moments that matter to our customers. And the AWS Health Service has been integrated with the Splunk app for AWS since launch, and Splunk has been a phenomenal partner for us, and we will continue to work closely with them to add more exciting features. We will also invest in additional partner integrations over the next few months. And we will deploy AWS Health into the AWS GovCloud and the AWS China regions. In all other regions, we already have a presence. And we'll also work on offering automated remediation steps that can be attached to events on customer consent to help heal the infrastructure. This is an extension to the demo that I showed with the Lambda capability. Very soon, we will make code examples of the AWS Health remediation automation available to all of you. And we are also working to provide plugins to Slack, SNS, and SMS channel. And here are a few useful resources. So you can learn more about the dashboard and the APIs in that particular link. And I presented the dashboard link a few slides back. And API documentation is provided in the third link there. And again, the CLI and API are for business and enterprise support customers. And you can find out more about the Splunk app for AWS that's integrated with the health service in this particular blog post. There are more details there. And we are very excited to see the innovative ways that you will use the Personal Health Dashboard and the Health APIs to come up with new solutions. Thank you very much for your time today, and look forward to answering a few questions now.
Great. Thanks a lot, Ram, for a great presentation. I'd like to thank the moderators for answering the audience's questions as they come in. Please take a minute and reply to the polls you are now seeing appear on your screen on the left-hand side, and there's also one poll at the bottom. We have about 20 minutes left, so we're going to start answering some of the questions that have been submitted. Please continue submitting your questions. The moderator is going to keep replying, and we're going to send some over to Ram to take live. Ram, I'll now hand it back over to you.
Thanks, Ryan. We have a question from Ben Merrill. Will these custom notification rules be able to be integrated with third-party event monitoring systems? The answer is yes. So you could use two ways to integrate these notifications with your in-house monitoring tools. One is you could use the AWS Health APIs or command line interface and call the APIs and extract information of interest, and then hook the output to your in-house system. So API is one programmatic way. And the second way is through CloudWatch events. So as I mentioned, you could author custom rules to extract events of interest, and then provide targets that are integrated with your in-house tool. So I showed Slack as an example. So if you have other ways to integrate with other tools that you use through a callback URL or any kind of other integration, then you can use different routing mechanisms based on severity, which is customizable based on your requirement. And you could plumb these events to various other integrations so that you can kick off automated workflows internally. So the end goal with these integrations is to really reduce your operational burden of managing complex applications as you grow your usage on AWS. I have a question from Patricia Uper. The question is, I currently support 2 different AWS cloud environments. Will this require 2 different logons for PhD? If the 2 cloud environments are in the same account, then you wouldn't require 2 logons because we provide an account-wide view at this point. So if you've differentiated your 2 cloud environments through different VPCs or different tags, or there is some kind of differentiation, in that case, you don't need different logons. However, if your 2 cloud environments are in different accounts, 2 accounts or more, in that case, it would require multiple logons to the Personal Health Dashboard. And if you're using the APIs or CLI, it means iterating over multiple account credentials to aggregate data yourself. At this point, we're providing only a single account view. As I mentioned, over time, we will work towards providing a multi-account view because that has been a feedback we've heard from customers who run mission-critical applications whose usage is generally spread across multiple accounts. There's a question from York White. I hope I pronounced your name correctly. Can I use IAM to limit access to the Personal Health Dashboard, like limit to just database alerts for the database team? The IAM support at this point is scoped at a level of all event types, so whether you can access an API or you cannot access an API. So we do not have granular IAM permissions available yet. We will work towards this. It's something that we are strongly considering because we need the ability to restrict what events are visible to which particular teams. At this point, it's blanket access. Over time, we'll work to provide granular access to events based on the type of metadata. There's a question by Reza GT. The question is, what is the relation between Personal Health Dashboard and the Trusted Advisor? I'd say that the Personal Health Dashboard and Trusted Advisor work in a complementary way to help customers architect well and run their environments well on AWS. With Trusted Advisor, you get best practice recommendations in 4 categories of cost optimization, performance, fault tolerance, and security. So if you follow these best practices, you're well architected on AWS. This, however, does not mean that an underlying issue is not going to occur because, as Werner said, failures occur all the time. So it is during scenarios where a failure occurs, Personal Health Dashboard comes into play, where it provides visibility into issues that are occurring in the underlying AWS infrastructure. So it is for you to take timely actions for any issues impacting your infrastructure. So with Trusted Advisor and with Personal Health Dashboard used in a complementary manner, you'll be able to run reliable, scalable, and secure applications. In an ideal world, you would have 0 health notifications because there are no failures at all. But you could still have best practice recommendations because there may be some user issues with configuration and so on. So the 2 used in conjunction, I think, provides best value to customers to architect well on AWS. There's a question from Dean Trejo. Is there a cost for this? The Personal Health Dashboard, the console, the UI part is free for all AWS customers. The CloudWatch events output channel is again available to all customers. Only the health APIs and the command line interface are restricted to customers who are on business and enterprise support customers to power their integrations. I hope that answers your question. There's a question from Alex Au. The AWS config rules will have some results that are not compliant. So I am wondering if the health service includes the information of AWS config rule results that are not compliant. We have heard this feedback from customers before. And we are working with the AWS config team to surface notifications or information when there are rules that are not compliant. We will be coming up with this in a few months. There's a question from Michael Goldsworth. Are events and notifications available to digest to services external to AWS? For example, if you wanted to tie events into an existing Zabbix solution that is handling events for on-premise physical machines to allow for unified visibility of our total grid capacity, is that possible? Yes, I think I answered a similar question. So you can use the Health APIs and command line interface to integrate the events and notifications to your in-house monitoring and third-party tools. So you could use the APIs and the CloudWatch events channel, or you could also use the Splunk app for AWS because it offers out-of-the-box solution to integrate. And we'll be investing in additional partner integrations this year. And to just remind you, the Health APIs and CLI are available to customers on business and enterprise support to power their integrations. There's a question from Sam Helani. Does administrator access include the policy for PhD? Yes, administrator access does include the policy by default. We also included the policy by default for several other default policies such as power user and read-only user. This is because the alerts on the navigation bar in the management console is present across service consoles, and we want most customers to make use of this notification. So the alert widget, since powered by the Health APIs, we made the IAM policy available for read-only access as well. Is the Personal Health Dashboard available in the AWS GovCloud region? Not currently. The GovCloud region is something that we are going to add support for in the future. At present, we have availability in all the other 14 regions. The 2 regions that we do not support today are the AWS GovCloud region and the AWS China Beijing region. There's a question by Jason. When I access Personal Health Dashboard and select Event Log, I'm seeing events in regions where I do not have resources. I could understand that on the Service Health Dashboard, but my understanding of PhD is that it's only going to give me items that may be impacting resources associated with my account. Why is that? So we heard feedback from customers about this, and they wanted the Personal Health Dashboard to be the centralized repository for both personalized information that is resource specific, as well as events for at a service level. So you will see sometimes in the event log section, events for regions and services that you do not have usage for, but we wanted to provide this centralized view so that you could use Personal Health Dashboard and not use Service Health Dashboard if you're a customer of AWS. And over time, we will better this experience so that we are able to differentiate the events that are specific to you based on your service usage and show events for services that you not use in a different way. But at this point, it's all provided in a single place of view, and we will work to make this better in the future. There's a question by Vijay Kumar. Is the 90-day history in the event log section the limit, or can it be changed? At this point, it is 90 days for all types of events. We want to hear your feedback, and over time we will tweak this historical limit either as a blanket for all the types of events, or change this limit based on different types of events, based on use cases that you have. We've started off with 90 as of today. So it's similar to, if you see how we handled Service Health Dashboard, we supported 30 days in the beginning. We changed that, we increased it, and today we support 371 days of historical view. So we want to follow a similar approach where we launch with 90 days. We want to hear your feedback and change this limit based on what makes best sense to our customers. There's a question by Dean. How can I specifically integrate with CloudWatch? So there we have very strong documentation covering some of the basic integration options and possibilities. So for CloudWatch specifically, we have a section in our documentation that talks about this channel. So you can refer that. Over time, we'll also add a few code examples and provide them to you so that it becomes really plug and play for you to use these various code samples. With CloudWatch events, we automatically publish all customer-specific events into CloudWatch events. So the configuration you will need to do is in terms of authoring rules and setting up targets. So with rules, you can be general by capturing all health events or be specific based on rules that you have. So you could either use the CloudWatch Events UI to create these rules or the CloudWatch Events API to author these rules. So you can take a look at the documentation that we have, which have instructions as to how you can handle this. There's a question, is there a resource or email subscription for keeping tab on specific partners we'll be integrating with? We'll be making this information available on our website. So it's the premium support / PhD website. So we'll list all the partner integrations and various success stories there. So it was the first link in the resources section. So you can keep a tab on that to look at additional partner integrations that we're going to have in the next few months. If your company has a team managing AWS Access, will individual users have access to rule creation, notifications, etc. for their own VMs and environments? If it is specifically for rule creation, then it depends on whether the individual user has access to CloudWatch events, because we're using CloudWatch events as the mechanism to create rules and publish events. However, if you're thinking of creating rules using the health APIs, then the particular IAM user will need to have access to the health policy, which I showed in the slide. So this user should have access to the health APIs and command line interface. And if it is notifications, it is similar. So with notifications, if it is CloudWatch events, then they need to have sufficient IAM permissions to access the CloudWatch events channel. And then this becomes available to users in the particular team.